Hello, everyone. Welcome to Approach to GMAT Questions segment. My name is Joshua Ubuya, a GMAT trainer and coach with the Kenya ELIT program. We'll bring you questions that are from the GMAT exams and show you how you can approach them in both quant and verbal sections. You check out our other videos to find out more. In today's session, I'd like to look at the maximum and minimum value kind of problems in the GMAT problem solving section. There are several topics which these can cut across, but today we'll focus on those which fall under the number theory topic. So for starters, as you may know that the number theory topic is a quite broad, one of the most tested topics in the GMAT exam. It's because it has lots of variety of applications and testing approaches when it comes to the GMAT exam. So let's just dive right in and see what we have. So first and foremost, before we can get to be able to get the questions, you need to be very conversant with the concepts that come with these kind of problems. So if you take a look at study materials, they talk about being able to minimize all the values if you want to find the maximum value. That is what is true. Because if actually it's just the logic that comes with it. For instance, if actually you have numbers, let's say X, Y, Z, Z, yeah. Excuse me. Say, let's say you have numbers X, Y, and Z. Yeah. If you have those three values, I'd like to find the maximum value of them given some conditions. You need to minimize the other ones. For instance, if all these, they can add up to, let's say, 100. Yeah. They can add up to 100, let's say X plus Y plus Z. Find the maximum value of Z, you need to minimize the other values of Y. If actually they add to 100 stays. Yes, if you actually find the maximum value of Z, you need to minimize these other ones. So for the minimum value of these ones actually depending on the conditions. If they're greater than 0, then the minimum value for X and Y can be 1. And then Z can be 98. That is if they're integers. If actually there's no restriction, it can be the maximum possible value. That can be 0.999998. That can be almost 9.9998. Then the other two can be 0.0001. Depending on what constraints are given. This is the maximizing principle, the maximum concepts. The same also applying to finding the minimum value. Maximize all the values. Yeah. If you find the minimum value of these three, let's say X plus Y plus Z, minimum value of actually, if actually they're not equal, so let's say 100, then minimum value of, let's say, X, it could be 1 if they're integers. What if actually it has to be, what has to be only one value, which is the minimum, and the values are not similar. You need to maximize Y and Z. Yeah, so Y and Z can be equal, so which means X plus, let's say, 2Y equals to 100. So if actually it has to be, then it can be, probably if it is integers, then it could be, they could be probably just 2. Let's say it is 2, because 2Y have to be an even number. So if it's 2, then actually means 49. Y and Z could be 49 each. 49 each, 49. Then Z can be X now can be equal to 2. Yeah, that is if at all they're integers. And that is the maximizing and minimizing value principle. You can read more about it. This is just an overview and a summary. And there are quite a number of other constraints which may come to it, which may come with it, and need to clarify on that. That thing, you need to apply logic and reasoning based on the topics which are being asked on. For instance, if it is a number theory kind of topic, then you'll only need to apply the logic and reasoning based on number theory concepts. If it is algebra, you need to apply logic and reasoning based on algebraic concepts. If it is other topics, let's say speed, distance, and time, the same applies. So knowledge of the concepts will really help you in being able to approach GMAT-related concepts. With that said, let us dive into the question. The first question is a sub 550 kind of question. This is a question which they're considered easy to tackle. And actually, it's easy to tackle in that many students don't have a challenge answering to this kind of questions. And if you look at these questions, they only require just a bit of the concept knowledge and just plugging the concept into the question required, and you get your answer. So if k is an integer, what is the smallest possible value of k such that 1040 times k is the square of an integer? For this one, you can pause the video, give it a shot, and then you can unpause and follow this with us. So if you can see that you need to get the smallest possible value of k such that 1040 multiplied by k gives you the square of an integer. Yeah. So being asked for actually 1040 times k gives a square, so which means if you find the square root of this value, it should be an integer. But how do you go about this? So when you look at this question, what comes to mind when you see squares and integers? It's the concept on factors, exponents, and prime numbers. That's what comes to mind. And if you also look at the properties of squares of a number, which is also a concept which you need to know, that also is something which you can apply directly and be able to get the answer. So one property of squares or squared integers is that they have even powers. Therefore, the most appropriate thing to do first would be to prime factorize 1040 and then see what you can get as the prime factors of it, and that will inform what the value of k could be or should be. So let's prime factorize it. We have 1040 and find the prime factors that come in it. So you have 2. We'll go 1040, we'll go here 5, then 20, then 2 will go here. Go here to 2, that is 4, twice 2, let's say that is 60. Then 2 will go here, 1, 3, and 0. Then 2 will go here, 6 and 5. So 5. The next prime number here now is 5. We'll go here 13. Then 13 will go here once. So you have 1, 2, 3, 4. 2 raised to power 4 times 5 times 13. So from here we see that the 2 prime number has an even power already. 5 and 13 have a single power form. Therefore, to make this an even number, we need to make this also have an even power form. And to make this a power form is actually the smallest that you can make it a power form is if 5 becomes squared and 13 becomes squared. For this, we'll need to multiply again by 5 and 13. And this will make it now 5 squared and 13 squared. And 5 times 13 is equal to 65. And that is the answer, choice E. Yeah. So that is the smallest possible value such that 1040 times k is the square of an integer. The smallest possible value. So that is how you go about it. Yeah. Let's go to the next question. This question will be considered about 600 to 650 level, right? Not so difficult as well. This kind of question, they require a bit of more logic and a bit of reasoning as well, and probably could have other topics coming in, but not so complicated. If you know your concepts well and you can apply the logic and reasoning to it, you should be good. Mainly find that you start combining multiple topics as you go higher in difficulty. So let's take a look at this question. If the average of 5 positive integers is 40, and the difference between the largest and the smallest of these 5 numbers is 10, what is the maximum possible value for the largest of these 5 integers? Pause the video, give it a shot, then come back again and let's hold it together. So we have 5 positive integers. Let's say A plus B plus C plus D plus E. If you find the average, it is 40. Find the average, you sum all the digits and divide it by the number of digits. So divide by 5 is equal to 40. Yeah. Therefore, for this reason, now if you proceed ahead and find out now that next thing that you can get is the sum of these digits is 200. So A plus B plus C plus D plus E equals to 200, because just multiply all through by 5, you'll get that is a value. What else have we been told? We've been told that the difference between the largest and the smallest of these 5 numbers is 10. So E minus A, if E is a maximum value and A is a least value, is equal to 10. That's what we've been told. Therefore, E equals to A minus A plus 10. That's what you can tell from this. So you see now algebra coming in this question. Yeah. Therefore, you to find the value of E. What is the value of E? Yeah. Now, this is where now the next thing I wonder, what could the values of B, C, and D be if E is actually 10 plus A? This is where now the concept now comes in for maximizing and minimizing values. Yeah. The concept comes in at this point in time. So what does this become? So find the maximum possible value of E or of A, or the largest digit in this situation. We need to minimize all the other values. Minimum value possible for all the other values in this set of positive integers is if they are equal to the minimum value possible. So you can make B, C, and D be equal to A. And then now E will be A plus 10. Now, if actually they're all equal to A, then actually find the maximum possible value for E. So that will be, we'll have A plus A plus A is now for C plus A 1, 2, 3, 4, 1, 2, 3, 4. Then the fifth digit now being A plus 10 is equal to 200. Now you have an equation which is very simple and easy to solve. This will be 1, 2, 3, 4, 5A plus 10 is equal to 200. Therefore, 5A is equal to 190. A is equal to 5, will go here 3 times into 48 times 38. So the value of A is 38. Therefore, E equals to A plus 10 is equal to 38 plus 10 is equal to 48. That is answer choice D as in dog. Yeah, I hope that is clear.
You're watching Success with Bob Mwiti Show, presented to you by Upstech America. Upstech America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstechamerica.com. Upstech America, we wake you up to the unlimited potential.
Okay, let's go to the next question. These are now questions which could be considered also again now 650 to 700 kind of difficulty. These are questions which require, they now cut across several topics and they require a bit more of logic and reasoning and may not be so easy to point out and see, but it's still doable. So in a certain class, 70% of the students learn physics and 65% of the students learn chemistry. What is the smallest percentage of those who learn both physics and chemistry? Yeah. So pause this video, attempt it, then you can pause it, we proceed again. Okay. So this question, it looks tricky, but whenever I see two groups being compared against each other and being asked, and you see there are some overlapping kind of sets question, because there's now seeing an overlapping set, and you're seeing now there's a minimum also value coming to it. Then that point, I prefer using the tables, the matrix structure kind of notation or expressing the values, reason out and logically find the answer to the question. So in this class, you have students who take physics and chemistry. So, but then again, there's some who don't take physics and some don't take chemistry. So you can say we have those take physics as in P, and then no physics. We don't take physics and P. Then you have those who take chemistry, then C, and don't take chemistry. So let's have this as a matrix. Then on the extreme end, we have the total. Then here also the total. So this is normally it works for any kind of values. Depending on whatever values you have, you just substitute them and you can have algebraic notations and proceed. So you see that 70% of the students learn physics. So physics, for those who take physics, all of them, that is this column here. Yeah, this column here, they're 70%. So for those who take physics, there's some who take chemistry and some don't take chemistry, but 70% of the students take actually physics. And then 65% of the students take chemistry. So for those students who take chemistry, some take physics, some don't take physics, but they all come up 65%. If you add these, or the total of it should come to 100%. That is logical speaking, because all the students actually population should be 100%. Therefore, this will mean, now let's change the colors a bit of the pen just to make it a bit more visible. This will mean those who don't take, actually also who don't take chemistry at 35%. Those who don't take physics at 30%. The question we've been asked is the smallest percentage of those who learn both physics and chemistry. That is this cell here, physics and chemistry. So you'd like to find out the smallest percentage possible. Yeah, smallest percentage possible. So that one will actually be informed by these two cells. Those who don't take physics and those who don't take chemistry will actually be able to help us give an insight onto those who don't take, let's say, Y, and then I can call this one Z. Yeah, we'll be able to inform on how many do not take chemistry, how many don't take this. That means that for you to find the smallest possible of those who don't learn both physics and chemistry, the smallest, to minimize this, yeah, we need to maximize this. Maximize that, and also maximize this other one. Yeah. You need to maximize those two. If you maximize these two, then you can minimize this. That's what the concept now comes back again. Now, let's look at it this way. The maximum number of students who actually may not be taking physics. In this situation, if you look at it, it could be probably 30%, because if you have 30%, that is the maximum number of people who don't take physics. So if it's 30%, then this will have to be 0. It also minimize this no physics, no chemistry. That is now how we can maximize the other one also, or actually we can also maximize this one. But in the situation, it's easier to actually consider this as 0. So let's say 30% don't take physics. And if at all this also is 30%, let's just write it there, 30%, as a reason out and see what other possibilities it could have. Then that means that this is possibly now could be 65 minus 30 will be 35. Let's see. Let's now come to those who actually don't take chemistry. If you have actually those who don't take chemistry, or they call them, those who don't take chemistry is 35%. And actually also those who actually do take physics, some of them are 70%. Then the maximum value that you can have for those who take physics and don't take chemistry could be that 5%. Let's write that on here too. 5%. The 5% of the students don't take chemistry. That 5%, 30% of the students don't take physics. Don't take physics, yes. So with this one also, if you look at again, if you actually subtract that 5 from 70, it comes to that 5%. So that means that we're getting the same value, yeah, the same value across the matrix, because across it should add up to this percentage here. Should add up to the percentage, and also vertically should also add up to the percentage. So 35 plus 35 should give us 70, 35 plus 30 should give us 65. what I was looking at is being able to find a value which completes this matrix in a way that it makes sense in its entirety. And therefore, we have 35 being the common digit that actually that satisfactorily fits into the constraints given. Yeah. So you have 35 as the number that is coming out. So 35% is value. So as you can see that this question, it could be difficult. It could be deemed difficult. But if you look at it also from the flip side, by just reasoning and applying the concepts and maximizing and minimizing, it becomes doable. The question is, what makes it difficult is not the overlapping sets aspect that comes with it. That's what makes it the 700 level question. So your knowledge of concepts across the topics and also the application, also the reasoning and logic that you have in your application really determines how actually you can be able to respond to questions in the GMAT exam. So let's take a look at another question now, which is more or less now very close to 700 for actually as can be viewed. Let's take a look at this one and see actually how we can attempt it. So I can pause the video, attempt this question and come back and let's see how to solve it. If 2 over x cubed is less than 0.02, what is the least positive integer value of x? Just as simply put as that, but as humongous as it may seem. This is considered it was considered a 700 level question, but I don't think it is really that difficult to be considered a 700 level question. I will probably put it in the 650 to 700, but very close to 650 level. So if I look at the quant scale, it could be maybe values of the quant score of 48, maybe 47, 48, thereabout. But not 49 or 50. I don't think it gets to the 50. I may be wrong though. Yeah, so pause the video, give it an attempt, and then unpause and let's follow along. So we're being asked for the least positive integer value of x. Yeah, that will make this fraction less than 0.02. That is what is being asked. Now, something else in number theory, if you're actually dealing with two forms of numbers, we have a fraction and we have a decimal. Convert them to the same notation. Because we may not be able to convert 2 over x cubed, you can't convert to decimal simply because we don't know what x is. It's easier to convert 0.02 into a fraction because you know what that stands for. So it will have it as 2 over x cubed is less than 2 over 100. So whenever you're comparing fractions and you're seeing one aspect, whether the numerators and denominators are matching or resembling to each other, don't touch them, just leave them as they are. Because what this informs is that already we have our numerators intact. So we need to now compare the denominators and see what will make the difference. So the concept here is that for you to have a value less than 2 over 100, x cubed must be greater than 100. That means the denominator needs to be greater than the numerator for it to reduce the overall decimal value of this thing. Just like 1 over 10 and 1 over 100. By increasing the denominator, you make the decimal small. This will be 0.1 and this will be 0.01. Have 0.1 for that. Then this one will be 0.01. Yeah, so 0.01 is less than 0.1. By just making the denominator bigger, that is what is happening. So we need to find values of x cubed greater than 100. So, and these are now, we don't even need to calculate because actually what you can see, as you can see that for a value of x greater than 100, you just need to find, you can easily just try them out and see. So like, for instance, we could start with 1 or 2, but no 2 cubed is 8 and 3 cubed is 27. So if 3 cubed is 27, 4 cubed is 64, and then 5 cubed is 125, and then 6 cubed 36 times 6 is 216. Maybe not wrong, could be wrong, could be, maybe, just not sure. But you don't need to get to 6 cubed, yeah? Because you're looking at a value which if we find its cube, it will be greater than 100. and you find the least. So you don't need to get the maximum possible value could be infinite. It can go on and on. The larger this value becomes, the smaller the fraction will be. Yeah. So you don't need to go all the way. But you just need to get that single positive integer value that will make this less than 2. So 4 will be greater than 0.02 simply because it is less than the denominator. But 5 is the sweet spot here. It's actually 125 greater than the denominator, and therefore it will make this whole fraction less than 0.02. So this is our golden value that we're looking for in this question. And therefore the D is the answer. So it really actually doesn't really have to be a difficult question, but just the knowledge and application of concepts changes the game. Well, that's what makes these things manageable, or makes these questions manageable. And that's what the GMAT tests. It tests how are you able to apply the concepts? Do you know the concepts, and are you able to apply them? Are you able to logically reason around questions to find the correct answer? So if you can do that, then that is what the GMAT exam is testing. So thank you for attending this. That's the end of today's of this video. You can watch other videos that we have as well on other topics and other approaches. You can also consider joining our training program if you'd like to learn more on how to be able to ace a GMAT exam if you're from Kenya or Africa generally. Our training is geared towards people actually whose exposure to the exam is not westernized per se. So that's something we focus on, and we can have that. And you can have them both. So go ahead and join and consider joining the session. If you like this video, share it, subscribe, and also consider letting others know. Give me comments if you have other questions you may like us to take a look at. And until next time, bye.